Now we'll look at inverse trigonometric functions. We start off by looking at this right-angled triangle, and we might say that the sine of A is equal to the opposite of the hypotenuse, 3 over 5. Now we've met the inverse sine function before, and we can just say that inverse sine 3 over 5 is equal to A. In other words, A is the angle whose sine is 3 over 5. And this idea is very important. When doing questions involving inverse functions, or inverse trigonometric functions, it's very important to remember that the inverse of a trigonometric function is an angle. So for instance, in part 1 here, we are looking at arc sine 1 over root 2. In other words, we want to find the angle whose sine is 1 over root 2. So let maybe y equals that. So y is arc sine 1 over root 2. This means that the sine of y is 1 over root 2. And if we go to our tables, and if we look at our tables, we can actually see that the sine of some angle is 1 over root 2, and that angle is 45 degrees. So that means that y is 45 degrees. In other words, arc sine 1 over root 2 is equal to 45 degrees. Let's look at another part of the question. We'll look at part 2. So this time it's arc cos of a half is what we want to find. So do the same thing. We'll say y equals arc cos a half, which means that the cos of y is equal to a half. And we look at this little grid here, and we go across cos, and we see which one of them has a half as the answer, and it's 60 degrees. The cos of 60 degrees is a half, so that means that y is equal to 60 degrees. In other words, arc cos a half is 60 degrees. In this question, we have to draw a triangle. Always when we're talking about these, they're right-angled triangles. So we're going to start off with our right-angled triangle. And the first thing we know is that we're looking at arc sine 3 over 5. Remember, that's the angle whose sine is equal to 3 over 5. So we'll call it y is arc sine 3 over 5. In other words, the sine of the angle y is 3 over 5. So in our right angle triangle, if this is the angle y and the sine is 3 over 5, it means that the opposite is 3, the hypotenuse is 5, and then of course using Pythagoras we'll get this third side here to be 4, and from that we can notice that it's mentioning arctan here, but from our diagram we can see that the tan of y is the opposite over the adjacent. So the tan of y is 3 over 4, and that means that y is equal to arctan 3 over 4. Now we have y is equal to arc sine 3 over 5, and y is equal to arctan 3 over 4. We'll just put a little circle around both of those. And we can conclude from that that arc sine 3 over 5 is equal to arctan 3 over 4. We're asked to evaluate something here, the sine of arc cos 3 over 5. Remember, arc cos 3 over 5 is an angle, so we can just call it y or something, and we'll start with that. So let y be the angle arc cos 3 over 5. That means that the cos of y is 3 over 5, and then we can draw that, show it in a right-angled triangle, the angle y. So the cos, the adjacent over the hypotenuse, 3 over 5. We can use Pythagoras to find the other side, 4. And now we want to find the sine of this angle y. So sine of y is the opposite over the hypotenuse. So the sine of y, or the sine of arc cos 3 over 5 is equal to 4 over 5.